Hi guys, so in this video, I'm gonna explain about the continental drift theory. So, first of all, let me make a point clear that continents were not in the present condition billions of years back. They were mostly joined together as a supercontinent called Pangaea, and further forces caused the breaking of the supercontinent and the relative motion of the continental plates such as India, Nazca, Eurasia, Africa, and more. So, through this video, I'm gonna give you guys a basic about the continental drift theory. So, let's start. The drift theory mainly has the point that is the continents present today is a part of a supercontinent Pangaea which have been splitted billions of years ago. So it's really necessary for us to know about the history of the earth. So we all know that our earth is formed billions of years back, roughly 4.5 billion years ago. From that period onwards, Earth has undergone severe tectonic and volcanic activities, which in turn caused the transformation of the Earth's surface. Earlier, different supercontinents were formed, then it started to split apart. So, before diving deep into this concept, we must take a look into the interior of the Earth. As we all know that the interior forces are one of the major factor which causes the movement of the tectonic plates or the continents. So, let's take a look on that. So, our interior of Earth has a depth of 6,371 kilometer, and as the depth increases, the temperature has also been increasing. Like it is mostly molten down there, and the rock shape as well as the density will also be increasing as we go deeper into the Earth's interior. So, it is broadly categorized into three layers. So, the inner part is called as the core. The denser materials will be mostly present in the core, and the other part is mantle, and the upper part is called as the crust. So, between the crust and mantle, there is a semi molten layer, and it is called as the asthenosphere. It mostly acts as a fluid, and the crust is almost solid. So what happens is that the crust or the plates floats in the asthenosphere. In the case of drift theory, it floats in the asthenosphere. Likewise, an ice is floating in a water. And there may be many kinds of forces that will be happening from the interior of the earth, like mantle convection and other pressure and temperature condition, which causes the force which makes the pressure difference and makes the plates to move relative to each other, and this constitute the plate motion. So, now let us take a look on the person behind this wonderful continental drift theory, and his name is Alfred Wegener. He is the one who made the continental drift theory and studied more and understand about the motion of the plates. Wegener was convinced that all of the Earth's continents were once part of an enormous single landmass called Pangaea. He is also known as the father of continental drift theory. Wegener is trained as an astronomer, used biology, botany, and geology to describe Pangaea and continental drift. For example, fossils of ancient reptile Mesosaurus are only found in the southern Africa and South America. Mesosaurus is a freshwater reptile only 1 meter long and couldn't swim across the Atlantic Ocean. So, this seems that the plate has moved upon the Atlantic Ocean. Wegener also studied about the plant fossils, where some Arctic regions have plant that only is seen in tropical climatic regions. So, this suggests that the plates that were once in the tropical region may have shifted to the Arctic region, which causes the presence of tropical plants. So now, how does the plate move? While the mechanism are still being discussed, the current thinking is that the upper mantle of the earth is in a state of convection with hot material rising under the diverging zones, that is plates moving apart, and cool material sinking in subduction zone, that is one plate diving and sinking underneath another plate. At converging plate boundaries, the plates collide and either mountains are formed or one plate is forced down into the other plate's mantle, and it is called as subduction. At transform plate boundaries, one plate slips alongside the other in opposite direction. So, this relative motion of the plates with each other causes the different geological structures like hills or trenches in oceans and may causes the motion of continents upon a greater scale. Other forces which may act upon the plates which causes the movement of the plates are mantle convection. It is caused by the inner pressure of the magma or other volatiles. And the next one is rotation and revolution of the earth. It almost causes a negligible amount of force, but it also can be noted. Then is the gravitational force, which is a force which is also affected by most of the or all of the living forms or non-living forms of the earth. So it also has a part in the movement of the plate motion, even if it's negligible as the second one. So, the rate of motion of plates are really negligible while comparing to the vast area that it covers. Like, it takes billions of millions of years to understand the vast or the big difference it may cause by the movement. So, roughly, researchers shows that the plate almost moves from an average of zero point 0.6 to 10 centimeter per year, and this motion will not be understood by our naked eyes. So, mostly GPS, satellite images, and other geological aspects are used to understand the motion of the plates. So, now we are going to take a look upon the different evidence that we have about the continental drift theory. There are two types of evidence, historical evidence and recent evidence. So, now let's take a look upon the historical evidence that we have. The first one is the fossil content of the plants and different animal species. We know that particular species may only adapt or live in a particular climatic condition. But if we see that fossil in another adapting condition, we could say that the particular plate has moved to another region after its life period. So many kinds of tropical plants have been seen in semi-tropical or cold regions, suggesting that the plate has moved from the tropical region to another part. The second one is the pattern. Like all the continent has a different shape or size, and this can be joined together like a puzzle and it forms a single body or a single supercontinent. The third one is the geological formation that we see today. Like there are many kinds of geological formation which is caused by the plate motion like transform and convergent plate boundary motions. So, one among it is the Himalayan mountains, which is the well known and the youngest as well as still growing mountain ranges. So, it is formed by the convergent plate boundary collision of the Eurasian and Indian plate. The next evidence is the rock formation. Like by the method of correlation, we could find the different layers of rock and we could suggest that how the plates move and what were the rock composition as well as the stratas of the different areas. So, lastly, we're going to take a look upon the recent evidence of continental drift or plate motion. So, it is the drifting or the splitting of the African continent. So we have been recently seeing it so many times in the newspapers, news, and many articles. So GPS measurement show that across the East African rift, the Nubian and Somali plates are diverging at an average rate of 7 mm per year, slowly putting the continent apart. Today, the rift remains above the sea level, but as it widens, the land within the valley will sink and may create two continents separately. So, we are looking forward in future that the continents may separate as two different one, and now we are actually seeing the process of the continental drift. So, this is the latest or the recent evidence that we have now about the continental drift theory. So, hope you all liked the video. For more interesting fact about Earth, please like, subscribe and share this video. Thank you.